So hey students, today we are going to do some MCQs from hydrocarbons and it will be whole NCERT exemplar MCQs. So all the best for your examination and let's get started and do the hydrocarbons MCQs. Arrange the following in decreasing order of their boiling points. Okay, so here our answer goes to 4, that is N-pentane greater than 2-methylbutane greater than 2,2-dimethylpropane greater than N-butane. Okay, decreasing order of their boiling points, and as there is, you can see like more branching, so it will be having what you can see. Firstly we will see the carbon numbers and then the branching. So if they are more branch, then the less boiling point. Branching inversely proportional to boiling point. Okay, because here you can see there is lot of boiling, there lot of branchings. Arrange the halogens F2Cl2 Br2 and I2 in order of their increasing reactivity with alkanes. So our answer is this one, F2Cl2 Br2 and I2. Okay, F2 is very reactive with those alkanes. The increasing order of reduction of alkyl halides with zinc and dilute HCl is Rx plus Zn plus dilute HCl. Okay, so our answer goes to this one, because when a carbocation will be formed, it will be stabilized by the inductive effect, that I is greater than that of RBr greater than that of RCl. Okay, the correct IUPAC name of the following alkane is, so our answer is this one, 3,3-di 3,6-diethyl 1 minute 2-methyl octane 1 2 3 4 5 6 7 8, and then 3 and 6-diethyl 1 2 3 4 5 6 7 and 1 minute we are 1 minute force 1 2 3 4 5 6 7 and 8. So you can see like at 3 position and in 6 position there is diethyl, and at 2 position there is 2 methyl and then octane. Okay, 8. The addition of HBr to 1-butene gives mixture of products ABC. The mixture consists of, okay, so our mixture consists of A and B are major and C are minor products. A and B are why major? Because you can see like here, okay, because carbocation is stabilized by ERG, and if there is more electron releasing groups it will be more stabilized. Okay, stability. Which of the following does not show geometrical isomerism? So our answer is 4, because you can see the same groups are present here, so it will not form GI. It will not form GI. Okay, but here you can see there are different group F, Cl, H and D. So you can represent it like this is cis with respect to F, or here it is trans. Okay, and here you can see different groups are there, so different groups are there, so it will also form GI. So GI is formed by these. Okay, arrange the following hydrogen halides in order of their decreasing reactivity with propene. Okay, so our answer is this one. Arrange the following carbanions in order of their decreasing stability. So our answer is this, because you know that sp is sp2 and sp3 for stability of carbanion stability. Okay, depends on electron withdrawing groups. Okay, so here you can see that it is present, or and 1 minute. Stability of carbanion depends directly on EWG and inversely related to ERG. So our answer goes to 2, that is this one. Then you can see like electron releasing group is there, so its stability is less than that of the B, and then here it is electron releasing group, so it will destabilizes the carbanion. Okay, arrange the following alkyl halides in decreasing order in the rate of beta elimination reaction with alcoholic KOH. Okay, so our answer goes to 4, that is you can see when in the case first, what is going to form is CH2 plus. Okay, and it is stabilized by at as. Okay, and then CH2 CH3 as in case of second, and in case this one CH2 CH2 and CH2 plus, you can see like this. So we can say that A is more stable than that of C, greater than that of the B, because more groups are present here to give or release the electrons. Stability of carb cation presents directly on ERG and inversely to EWG. Okay. Which of the following reaction of methane is incomplete combustion? So our answer is this one. In which of the following questions 2 or more options may be correct? Some oxidation reactions of methane are given below. Which of them is our controlled oxidation reactions? So our answer is this one, MO2O3, and it is forming, it is the best one, CH4 plus O2 giving HCHO plus H2O in presence of MO2O3. Okay, and 4, that is CH4 is giving CH3OH. CH4 plus O2 is in presence of Cu giving CH3OH. Okay. Which of the following alkenes on ozonolysis give mixtures of ketone? So ketone is formed by 1 minute. Let's this, if it is of like this, then when you will hydrolyze, then it will form uh, double bond O and double bond O. Okay, so you have to see which one is 2 degree, and we will go with this one. Okay, this one is, because you can see like this box, and C and C is present, and then when you will hydrolyze, then it will form like this, C double bond O plus C C double bond O. Okay, and in this condition you can see like this, and in this one C C double bond C C and C, then you will hydrolyze, then it will O3 C C double bond O plus C C double bond O. Okay, which are the correct IUPAC name of the following compounds? So our answer is this one and this one. Let's see how. 5 secondary butyl 4 isopropene propyl decane, and this one. You can do some questions by your own self like this. Decane is it. 1 2 3 4 5 6 7 8 9 10. 1 2 3 4 5. Then you can see like this, this is secondary 5 secondary butyl Okay, and for iso, this one is iso, C, C and C like this, and then R is attached to it. So, and propyl decane. Okay, and 4, 1, 2, 3, 4. And here you can see like this. Okay, 1 methyl propyl decane. Okay, correct IUPAC name of the following compounds is. So our answer goes to 1 and 4. Neo means that it is surrounded like this, and iso means it is surrounded like this. Okay, so our answer was 1 and 3. How let's see, 1 2 3 4 5 6 7 8 9 10. Okay, so you can see at 5 position we will name 1 2 3. So here you can see 2 dimethyl, 2 dimethyl propyl because it's 3, and then decane, and then 5, this is neo pentyl decane. Okay, for a electrophilic substitution reaction, the presence of halogen atom at the benzene ring is deactivates the ring by inductive effect and increases the charge density at ortho and para positions relative to meta positions by resonance. What we are going to do is electrophilic substitution reactions. When a halogen is present, then what it will do is as electrophil. Okay, so it will be doing like this ortho and at para positions. Okay, by let it be X, so it will withdraw the electrons. In a electrophilic substitution reaction of nitrobenzene, the presence of nitro group, what it does is deactivates the ring by inductive effect and decreases the charge density at ortho and para positions of the ring relative to meta positions by resonance. In our first question, what we can see is like if it is X, then it will give and increases the charge density. But in case of like this one, it is EWG, then it will withdraw the electrons, and what happens is like this. Okay, which of the following are correct? This one is more stable than this one, and this one is more stable than this one, because how you can see, 1 minute, here you can see what is present electrons, then they will give the electrons to it, and it is in case of OR is greater than that of R, ERG. Okay, electron releasing groups. And in case this one is electron withdrawing group, and it will destabilize the carbocation, and it is electron releasing group, so it will stabilize. As we know that C plus or carbocation is directly proportional, stability directly proportional to ERG, inversely proportional to EWG, and 1 minute, and anions stability directly proportional to EWG and inversely proportional to ERG. Okay, 4 structures are given in option 1 to 4. Examine them and select aromatic structures. So our answer is this one and this one, because you can see sp2, this is, and here you can see there will be resonance like this. If it is plus, then it will be like this. So what you can see here, the plus charge will come here. Okay, so it will move from one place to the other, and from here it will come to, okay, so just it. The molecule having dipole moment is this one and this one, because how we can see 1 2 3 4 5. Okay, so trans 2 pentene is there, 19 2 and 3. Okay, so firstly we will make this and then we will form the transform. Okay, and then we will form the butane. 1 minute, note cis hexene 1 2. Okay, 5 and 6. So here you can see. Okay, so whenever there is R and R group, then it will be, if ERG group is there, it will release the electrons towards and they will not cancel out. And when the C double bond C EWG electron withdrawing group is here and electron withdrawing group is here, then the dipole moment will be present. And in case of how ERG electron releasing groups, okay, and here also electron releasing group is there. Okay, but what can happen is like this. But if a C double bond C EW is there and ERG is there, then there is dipole moment present. Okay, but if there is EWG and 1 minute, EWG and EWG, then no dipole moment, no dipole, because they will cancel out each other, cancel out. Okay, now we will see some match the following questions. Okay, matching type questions. So let's get started. Match the reagent of column A with that of CH3, gives some products given in column 2 as per the codes given below. So in presence of O3 ZnH2O, it will form acetaldehyde and formaldehyde. How we can see like this: CH3 CH double bond CH2. Then when this reagent will act, then it will form CH3 CHO plus CH3 HC, 1 minute, HCHO. Okay, and this one. But now the next one with this. Okay, so our answer is acetic acid and CO2, and with this one it will be forming propane 1,2-diol, CH3CHOH and CH2OH. Okay, and like this H2OH plus, then it will be forming propane 2-ol. I have a trick for this. You can learn it by pani pedaru. Okay, because pani H2O is present and it will give the alcohol, ROH will be formed. So you can learn it by this CH3 CH double bond CH2. Then when water acts, then it will form CH3 CHOH and CH3. Okay, propane 2-ol is formed. And when B2H6NaOH and H2O acts on this, it will form propane 1-ol. Okay, propane 1-ol will be formed. SN1 and SN2 are the most important to learn. Okay, and stability also. N-pentane, isopentane and neopentane. As you know, the boiling point inversely proportional to the branching. So which is more branched? Neopentane is more branched, so it will be having the lowest. Okay, and then isopentanes comes like this and N-pentane is this. So we can see like this. So just learn the concept that BP inversely proportional to the branching. Okay. Match the following reaction in column 1 with the corresponding reaction products in column 2. Benzene and Cl2 AlCl3. So what's gonna form is chlorobenzene like this. When benzene reacts with Cl2 in Lewis acid, this is Lewis acid, then what is formed is this one. Okay. Benzene plus CH3Cl in presence of AlCl3. Benzene is there plus CH3Cl in presence of Lewis acid. It will be forming methyl benzene. Okay. So our answer goes to C, toluene. Okay. And then benzene plus CH3COCl AlCl3, then it will be forming COCH3. Okay, so our answer is methyl phenyl ketone. This one. And now toluene. CH3 in presence of KMnO4 plus NaOH, it will be forming benzoic acid. C double bond OH is formed from CH3 to C double bond OH. So we can see that this will form benzoic acid. Okay. 1 minute. Now our next question is this one. So its answer is hydration because water is being added. Okay, and now this, in presence of PD, what we will do is hydration. So hydrogenation, it is addition of H2, add H2, then hydrogenation, and when water is added, then it is hydration. Hydrogenation is addition of H2, and in this case what you can see is halogenation is occurring because Cl and Cl are being added, and in this condition Cu tube there is polymerization. This reaction is very crucial, or because you can form directly the ring from aliphatic to aromatic when you have to go, then this reactions comes very handy. Okay, so all the best for your examinations.